Okay, we are recording these last two examples, and I will put this on the website as well, so you will have all of the notes from section 6.3 on the website, and I strongly suggest that if you are struggling with vectors that you re-watch these videos. There's two already on there, both recorded in this block 4, and then if I put this one on there, that will be a third video completing all of our notes from section 6.3. So in this example, it says find the component form of the vector that represents the velocity of an airplane descending at a speed of 100 miles per hour at an angle 45 degrees below the horizontal. If it's descending at 45 degrees below the horizontal, and if we're assuming that it's heading, in this direction, that would give us an angle of 225 degrees. And the velocity is really your magnitude of the vector. So remember that the vector v is going to be magnitude of vector v times cosine theta I plus magnitude of vector v times sine theta j. We could have also just written this as magnitude of vector v times, in component form, cosine theta comma sine theta. In this case, the theta is 225 degrees, and the magnitude is the same as the speed of the airplane. So that's 100. So we get 100 times cosine of 225i plus 100 sine 225j. And these are, of course, degrees here that we're talking about. All right. So what is the cosine of 225 degrees? Picture the unit circle. Isn't that like 5 pi over 4?
Negative. Yeah, 5
So negative. All right, so we get 100 times negative square root of 2 over 2i plus 100 times, what about the sine of 225? Same? Negative, negative, so negative square root of 2 over 2j. And if we're going to write it in component form, then we really want to kind of write this as what? 100 times negative square root of 2 over 2, isn't that 50? Negative 50 times square root of 2, comma, negative 50 square root of 2. Everybody agree with that? That would be the component form. All right. So that's that example. And let's take a look at one more. A component form does not have i's and j's in it. The i's and j's are for the linear combination of the standard unit vectors, I and j. All right, let's take a look at this next example. Oh my. Okay, this one is another airplane example. An airplane is traveling at a speed of 724 kilometers per hour at a bearing of north 30 degrees east. If the wind velocity is 32 kilometers per hour from the west, find the resultant speed and direction of the plane. All right? So for this problem, you see that we really have two vectors at work, right? Vector 1 is the airplane itself, and vector 2 is the wind. All right? And the wind is a force that's acting on the plane, so it's causing it to have, it's causing it to go a little bit off from its directed course, right? So vector v is going to be equal to v1 plus v2. We would say vector v is the resultant, that's supposed to be an arrow, of vector v1 plus v2. All right, cool. All right, so to get vector v1 is going to be the magnitude, which is our speed, 724, times the vector that represents the angle that it's going, so cosine 60 degrees, sine 60 degrees. And I didn't talk about that, but if it's north 30 degrees east. Here's north, 30 degrees east would put us right like this. So there's the plane, but in terms of its angle, we always have to describe this angle theta. This has got to be an angle with the positive side of the x-axis. You with me?
How did you get the vectors from separate?
Speed is always going to be your magnitude. The speed of a plane is going to be the magnitude of the vector. All right, so the theta, I can't use 30 degrees for theta because that's some angle associated with the y-axis. I don't want that. So I need the angle measured this way from the positive part of the x-axis, right? So that means my angle is really 60 degrees. So I've got cosine 60, sine 60. The cosine of 60 degrees is 1/2. The sine of 60 degrees is negative square root of 3/2. It's not. That's a bad mistake. My bad. Why is that on there? So when I distribute the 724, what's half of 724? 362. Perfect. And then we get what? 362 square root of 3, just like that?
Yeah.
End of story? Okay. Are we okay with this? That's, thank you, that's the component form of vector V1. Just vector V1. We haven't done anything with the wind yet.
Will you give us the diagrams on the top?
Yeah, can you not make us draw them instead of
You didn't like that problem on the last quiz where you had to draw your own?
I think I got them right, but not.
I looked at that, and like, how does that work? Let's do a drawing, it makes so much more sense.
All right, well, let me think about that one. Meanwhile, let's talk about this wind. The wind vector is vector V2. That is a force that's pushing on and acting on the airplane. All right, so if it's acting on the airplane, it's heading in a direction that is, what's it say? From the west, correct?
Yeah.
So that means it is going in this direction. So what angle does it have? 0 degrees.
Wait, can we do that one more time?
Since it's heading from the west, right? The wind is heading from the west, its angle is 0 degrees.
Oh, right, okay.
If it was heading from the east, which wind never does because our weather comes from the west, right? But if it was coming from the east like this, then we'd have to say like 180 degrees, right? You with me? Okay, so for vector V2, we can write that as 32, because it's 32 kilometers per hour times cosine of 0 degrees, sine 0 degrees. And so if I distribute, cosine of 0 is 1, sine of 0 is 0. So I get 32 times the vector 1, 0, which is just going to be 32 comma 0 in vector braces. So let's recap what we've done. We've written vector 1, which is the airplane vector, and in component form, and we get this. And now we've written vector 2, which is the wind in component form, and we got this. Two forces are acting on this airplane, right? The airplane's engines, I guess, are directing it in a certain direction, and the wind is directing it in a certain direction. So we're looking for the resultant, and to get that, we need to add these two vectors together. Rachel?
So like, the original equation is like x cosine theta sine theta.
Yes.
But how is like the speed of magnitude?
The speed of an airplane is going to be considered the magnitude of our vector.
What about this in?
Yeah, that would be the, right, sure.
I didn't know this.
Yes. Okay. So, when we add these two to get the resultant vector, I get 362 plus 32 here, and 362 rad 3 plus 0 here, and I end up getting my resultant vector as 392 comma, my bad, 394 comma 362 times square root of 3. Agreed? Okay. And that's not the magnitude, right? That's just my resultant vector V. Yes? Okay, so what is the question asking again? Let's see. We're supposed to find the resultant speed and the direction of the plane. We're not done yet, Cole. But wait, there's more. All right? So if we want to find the magnitude, that's going to be the resultant speed, isn't it? All right, so let's do that. So, all right, so we're going to find the magnitude of the resultant speed. A little help with your calculator, please. I need, what do I need? What'd you get for this one?
740.5.
Yeah, I got it right around 740 kilometers per hour. Do you agree with that? Can you confirm 740?
So question, if we have a number under the radical that's like this crazy big, we just actually figure it out. Instead of keeping it like
548,368. Instead of keeping it like that, could we just?
Yeah, that's fine. Just leave it. And now you're taking the square root of that
Well,
answer.
yeah.
Okay, did you get 740? Okay. All right. And what do we do to find the direction?
We haven't found the slope.
Wait, can we pause? Wait, can we pause for like 5 seconds? Because I'm just not there.
We already answered that.
So to find the direction angle, we have to use the component form. Think of this x coordinate, if you will, of your component form as A and the y coordinate as the B. And you know that the formula for tangent of theta is B over A. So in this case, tangent of theta is going to be 362 square root of 3 divided by 394. Can I get a decimal for that, please?
I feel like you didn't need that.
It's because he lost.
Oh, man. Like that? What'd you get for tangent of theta? What is it? 1.59. Do people agree? All right, and that would be the tangent of theta. So you know that that means we need to say theta equals tangent inverse of 1.59. True? Yes? So theta is equal to what? Do people agree?
Somebody did that.
1.01.
1.01. Okay, and what is that? That's in radians. So what is that in degrees?
57.9 degrees.
57.9 degrees. Now let me ask you, does that direction of our airplane make sense with the way the wind is blowing on it? Yeah, because instead of it going at an angle of 60 degrees, it's getting pushed a little bit off course and it's going at about 57.9 degrees. Are we okay with this? Awesome. All right. So I'm going to stop recording now. You got these last two examples recorded. I'll get these on the website, and I am ready to take your questions on 6-3, homework, A or B.
So many questions.
Yeah, I don't think I
15 to 19, all of them.